Okay, our next part says sketch a graph comparing Taylor's speed on the x-axis to her distance on the y-axis. So this is something that typically we're not going to see graphed, but we're just going to investigate it, really just to determine whether distance is a function of speed or not. Okay, so I rewrote some of our information from above down here. So we know that from 0 to 1 miles, she's maintaining a constant speed of 11 miles per hour. And you're also going to notice that I went ahead and already wrote my scales in. So I have speed on my x and distance on my y. So at 11 miles per hour from 0 to 1 miles. So if I think about that, that means at mile 0, I'm 11 miles per hour. So at mile 0, I'm at 11 miles per hour. And then all the way up until 1 mile, I'm doing the same. So for this entire distance, I'm maintaining that same speed. Okay. And then I stop and I'm not running at all. So I don't have any distance, I don't have any speed, so I don't even have to worry about putting that in my graph, right? Because my distance is stopping and my speed is stopping, although time is still moving on, which is why I was flat in this portion. I'm not graphing time on this, so I don't have to worry about it. And then I have my second portion that is telling me that from 1 mile to 2 miles, I'm 15 miles per hour. So at mile 1, started at 15 miles per hour. And then I started doing the whole time all the way up to here. So again, not really a conventional graph, but we're just investigating what it looks like. We have an issue here because it's saying that at mile 1, I'm running 2 different speeds, which seems a little bit odd. So we're going to investigate that down here further when I have that kind of overlapping piece and what that means. But right now, I just need to figure out, is distance a function of speed? So if I look here, I have multiple y values for my x value, right? At 11 miles per hour, I'm at 0, 0.5, and 1 mile. So although it's possible for me to do that, it's not a function. So keep in mind that when we're saying something is not a function, it's not saying that it's impossible. It's just saying that it's not a function because she is running the same speed for the first mile. She's running the same speed for the second mile, but graphing distance versus time creates something that is not a function. So we're going to say no. There are multiple y values for each x value. And again, we have another error here because it's saying that at mile 1, we're at 11 miles per hour and 15 miles per hour. So how can we run exactly the same pace or 2 different paces at exactly the same time? How could we maybe show that we're not? Maybe think about that, and we're going to look at this further on down in this example. But again, not a conventional graph that we would see. We typically wouldn't compare distance on the y and speed on the x, but if we did, we can see that it is not a function because we have those overlapping y values.